Welcome to our year in review of the sky above. I'm your host, meteorologist Leah Pezzetti, and I'm so glad you are here with me. The Sky Above is a brand new show we launched in 2025, a monthly astronomy show where we discuss everything astronomical heading our way that month so people know when to look up and witness some out-of-this-world events. It's been a smashing success, and I can't wait to continue it into the new year. But first, let's take a look back on some of the most interesting conversations from 2025. Every month, Seattle Astronomical Society member and NASA Solar System Ambassador Keith Crum joins me to talk about meteor showers, planets, and whatever's visible that month. We also always discuss the full moon and its origins. Here's one of those chats from October. What will a supermoon look like compared to the regular moon?
Well, it's about 7% larger, but about 30% brighter.
Okay.
So, that'll be really significant. Like if you're out on Alki looking back at the city, coming up over the city, it'll look bigger and brighter.
So this is visible to the naked eye.
Yeah. Oh, yeah. Visible. In fact, it's blinding to the.
Okay, maybe not visible. Hang on. It's noticeable. Let's say you will notice the difference. Okay, good catch. Good catch. Of course, the moon is visible to the naked eye. Okay, but let's talk about why. What makes this a supermoon? What is it that actually makes it appear larger and brighter? Because obviously, the moon is not growing.
Right. So it's closest to Earth at the point called perigee, because the moon goes in a slightly elliptical orbit, and so it'll be 225,000 miles from Earth. And is that what the graph?
226.
226.
It looks like it's around that.
Around that, yeah.
We're talking hundreds of thousands. What's another thousand?
Yeah, that's it, right. And then when it gets to apogee, which is the other end of the cycle, it's about 251,000.
Okay, and the cool thing about this supermoon is that it's not the only.
It's not the only
supermoon. Every supermoon for the rest of the calendar year will be super.
Yep.
And we typically see that.
Yep.
They come in threes.
They come in threes, and as a matter of fact, as I just found out, it's a supermoon in January too, on January 3rd. So we actually have 4 in this cycle.
Wow. Okay, so October 6th, November 5th, December 4th, and January
3rd.
January 3rd. Yeah. Okay, so mark your calendars.
Yeah.
It will be a super moon.
Yeah.
And I always love seeing the full moon pictures. Take photos for us, everybody. You heard Keith. 3 down, 1 to go. So enjoy the final supermoon stretch on January 3rd of 2026. The next one won't be until late November of 2026. While Keith keeps us on track for the monthly skywatching events, I also had new faces join me each month to talk about the latest discoveries and research into life beyond Earth. In July, 2 University of Washington professors joined me to discuss the newly launched Rubin Observatory that was unveiled at the end of June. UW was instrumental in getting the telescope up and running. Here's a bit of what we discussed. So let's first talk about what this project means for knowledge of outer space as a whole.
So Rubin Observatory will develop the deepest, widest, longest time-lapse movie of the universe. So we're going to see the volumes of space that we've never seen before. We're going to image all that with a big digital camera. We're going to put it in a computer. We're going to let all the astronomers in the world derive wonderful science out of it over the next 10 years.
And let's talk about some of the images that have already come out so far. It seems like immediately we got this incredible perspective. What have we seen so far that maybe we were expecting or were not expecting?
So what we've seen are the 2 images we've released so far have one of the deepest looks into cosmos in an area of the sky called the Virgo cluster. It's over 25 square degrees. It goes down to depths where we see stars that are, and apologies for the lingo, but 25th, 26th magnitude. Goes all the way to perhaps 1 billion years or so away from the Big Bang. We see tens of millions of galaxies in there. And what's really impressive about that image is that it is made essentially only a night worth of observing. And Rubin is going to observe for 10 years. What you see there, we're going to image 750 times as much.
Yeah. And I heard you say something, Mario, about how in history, our data collection of outer space, it just felt so slow. But how much has this sped up that process?
It's sped it up incredibly. So one of the other things we've shown is that we can discover asteroids with this observatory. And we put out the discovery of the first 2,000 asteroids. And to give you a sense of that, it took us about a night of observing to find those 2,000. Before Rubin, in the entire year, the entire world finds about 20,000 asteroids.
Wow.
So once Rubin is on the sky in the next year, we're going to double the number of known asteroids. And it took us 225 years to discover the first 1.5 million. The next year, we're going to discover the next 1.5 million. So it's amazing.
My December guest also discussed another key tool in space observation, the James Webb Space Telescope. December of 2025 marks 4 years since this telescope launched into space, giving another new and improved view of space. Emily Levesque, also a University of Washington astronomy professor, walked me through some of the highlights of what was discovered in 2025 thanks to the James Webb Space Telescope.
So James Webb got launched, like you said, about 4 years ago on Christmas Day of 2021. It's got a big primary mirror. It's just over 21 feet from end to end, so it's the biggest telescope we've ever put into space. And it's sitting almost 1 million miles from Earth. So it's at this stable gravitational point thanks to the Earth and Sun going around one another. And it's been constantly busy since we launched it. It's been observing for about the past 3.5 years, and it really does do groundbreaking new science pretty much every single day.
Oh my goodness. Okay, so we could sit here, I think, all day and just talk about what we've discovered so far. But let's go through the highlights, kind of rapid fire some of the biggest discoveries that came from the James Webb Space Telescope this year. You've chosen your top 5. Let's go down the list.
Yes.
We will begin with what is now currently the best and deepest view ever taken of the universe.
Yes.
Oh my goodness.
So we started with Hubble taking images called deep fields, where we would point the telescope to a seemingly empty patch of sky and just stare, because this is like with the camera taking a really long exposure. You just open the shutter and wait. So this new deep image from Webb stares at a tiny patch of sky. This would be like if you held a grain of sand about at arm's length, and it stared at that patch of sky for about 100 hours. So it was able to capture the very faintest and dimmest objects in the night sky.
Wow. Oh my goodness. And it's beautiful here right now.
If you pointed at that and just looked at it with a not quite as powerful telescope, it would look empty. But when Webb is able to put the full power of that enormous mirror on it and gather up all that light, you see this beautiful array of galaxies. You see tiny little faint smudges that are barely visible in that image. Those are actually the really groundbreaking objects that represent the farthest we've ever seen across the universe.
Wow, that's incredible. I can't even wrap my mind around that. Okay, and then another thing we talked about, stars dying.
Yes.
That's your expertise. Mm-hmm. We witnessed that. Mm-hmm.
Yes.
What happened there?
So an interesting thing about how stars die is that people may have heard of this idea of a supernova. So what will happen is a star much more massive than our sun runs out of fuel in its core. And that means that it can no longer run a little fusion reactor and sort of counteract its own gravity. That means the core collapses, the whole star tumbles after it, and you get this huge explosion that's incredibly bright. So we spot supernova explosions happening in distant galaxies, but one thing we're really not good at right now is predicting when a star is going to go supernova. We study the way these stars end their lives, we study the physics of how they work, but we're really bad at doing this on a human scale. We can say something like, oh, that star is gonna die any day now, meaning in 10,000 years. Oh. So when we see a supernova, it kind of turns into a murder mystery. And what we do is we go back and look at the spot where the supernova happened, and then we look at observations from other telescopes in the hopes that maybe we happened to catch a glimpse of the star before it died. And this year we caught a Webb image of a star before it died for the very first time.
Wow.
Yeah.
So this is huge.
It's really exciting because the galaxy that we spotted it in is about 32 million light years away, And the star that we spotted, we would never have seen without Webb, or we certainly would never have seen in such detail because it's enshrouded in this cloud of dust. Before stars die, they kind of undergo these violent shudders and puff off gas that cools off into dust, and that dust blocks our view. But Webb is designed to actually peer through that kind of dust and get a really gorgeous view of the star.
Oh my goodness, that's incredible. Wow. Okay. And another highlight of the year, we got a great view of the Milky Way.
Yes, well, we got a great view of the center of the Milky Way, which is another thing that Webb is very specifically designed to observe. So Webb observes light that is redder than the light that we see with our eyes. And that light is particularly good at punching through thick gas and dust that would normally block our view. So this is an image of the center of our galaxy and a little piece of the center of our galaxy where brand new massive stars are being born. So you see this like beautiful array of stars, you see this glowing gas in the picture, but in the middle of it, it kind of looks like a normal-ish night sky, a lot more beautiful, but it kind of looks like a dark sky with stars shining through it. And what you're actually seeing in those dark patches are clouds of dust that are so thick that even Webb can't see through it. So you're actually looking at a bright star and gas-filled center of our galaxy, and then clouds blocking our way, so it looks dark.
Oh my goodness. Yeah. That is incredible to see. Oh my gosh. Okay, let's see. Another one, we've talked about this on The Sky Above before, but space dust. We got some new images of space dust. What is this?
So I feel like space dust sometimes gets a bad rap because you'll hear people say like, oh, why are we taking pictures of space dust? Space dust is fascinating. We're peering through it every time we try to take any observation of the night sky, and that dust comes from stars. It comes, in fact, from dying stars or interacting stars. So this is a gorgeous picture that got taken of 3 stars that are actually all orbiting one another. So there's 2 stars about 20 times as massive as our sun orbiting one another about once every 170 years. And they're on big, wide orbit, so when they pass near each other, they almost collide and they rip gas off of each other, and that gas turns into dust and makes a shell that starts sort of floating out from the orbiting stars. They've done this about 4 times in the past 700 years, so these shells that you see in that picture are dust drifting away from pretty much every time the stars fought. There's then a 3rd star going around both of them and just sort of slicing a path through them. All of that dust is glowing at the exact color of light that Webb is designed to see. So we see this sort of luminous leftover of how these stars have been interacting for now hundreds of years.
While it is great to look at space, let's get there. Is there life on another planet? Will plans to get people to live on the moon come to fruition? Those are some other conversations we've had with monthly guests. We'll continue our recap after this break. Welcome back to our 2025 Sky Above review. It has been more than 5 decades since the Apollo program ended, but the race to space is back in full throttle. This October, aerospace consultant Roger Myers joined me to discuss the goal of not just going back to the moon, but living on the moon.
So NASA right now is preparing for the Artemis II mission, which is going to take 4 astronauts to lunar orbit. They will not land. The timeline for actually landing right now, the official timeline is in 2 years, 2027.
Is that overly ambitious?
Yes. There have been recent congressional hearings and a lot has come out about the status of the landers. SLS is ready. SLS and Orion, they're fine. They will take astronauts to lunar orbit later in February, I think is when is that mission, exactly. February of this coming year, American astronauts will be in lunar orbit again.
Wow.
But they won't land because the landers aren't ready. And the United States is using 2 landers, or pursuing 2 landers. One is a Starship base built by SpaceX, okay? And the other is Blue Moon built by Blue Origin.
Okay.
Both of them are behind schedule, and both of them have a lot of work to do. They're very complex missions to get them to Earth orbit, refuel them in Earth orbit, which has never been done before, get to lunar orbit, rendezvous with Orion, have the crew transfer to Orion, to the lander from Orion, and then land on the moon and come back to Orion. So it's a very complex set of missions. And the reason they have to do it that way is because they're trying to do so much more than we did with Apollo, right? We're trying to have a sustained presence.
So if you could best guess with what we have right now, when will we be established on the moon?
I would say probably a couple years after 2029 probably we'll have our first landing again, 2028, 2029, so a year or two later than what NASA was hoping for.
Okay.
And that's really because of the lander development timeframes. I mean, I'm speculating, but I think that's a lot more likely than 2027.
But that's just landing. We're not even establishing yet.
Correct, exactly. To establish, we're going to have to land a lot of cargo. We're going to have to land habitats. We're going to have to land a lot of equipment.
Yep.
We're going to have to land a power system.
And that's what I want to talk about, the power. That seems to be one of the biggest issues and solutions being discussed, is actually putting a nuclear power plant on the moon. How in the world, or out of the world, are we going to do this?
So it turns out that the key to doing this is, one, it's a very small nuclear power plant. It's not a big power plant like you see on, that powers our grids. So these are very small. They're like the reactor itself is like the size of your washing machine. And then the overall system, it's got a big radiator. It's got a lot of equipment that goes to generate the power, transmit the power to the habitat or to whatever equipment it's trying to power. But the important thing is that we're not talking about a big reactor. We're talking about small reactors. And there's a lot of work right now dedicated to making sure they're safe, affordable, and small enough to fit on a rocket and land on the surface of the moon. And I think that we can do that by 2030.
Wow.
With a focused effort, if we think it's important to do as a nation to establish a sustained presence on the moon, and that's a question for policymakers and for the government to answer. But if we think it is important, with a focused effort, we could do it by 2030.
That is incredible.
Yeah.
I want to talk about something very complex. It feels simple at face value, but it is very complex. Who governs space? Why is there this big push to get there right now? And what does that do with whose land it is?
Right. It's a great question. And to be honest, there's still a lot of uncertainty in the answers. There are a lot of legal questions. The Outer Space Treaty, which the United States signed, and is signed by most countries in the world, says that nobody can own property in space. So all celestial bodies are common property. But many countries have now recognized that you can own resources extracted from celestial bodies. So you can go to the moon, and while you can't own the moon, you can't own property on the moon, if you extract oxygen or water or helium-3 or whatever resource, you can own that. So one of the big questions that we have today is, how are those resources distributed on the surface of the moon?
Yep.
And if somebody goes and establishes de facto control, they may not own it, but they still control it. And so if resources are concentrated in ways that allow a sovereign nation to control them, they control those resources. And other nations won't have necessarily access to them. A nation might grant them access, but once you control that space, you control it. You can establish a safety zone around it, or you can essentially dictate how people can access that region of those resources. And so a lot of this is driven by uncertainty in where the resources are on the moon. There's a lot of interest today in the south pole of the moon, because they're permanently shadowed regions of the moon where water ice is believed, with very high confidence, we believe that there's a lot of water ice in the south pole of the moon, in the craters, the permanently darkened craters of the moon. So establishing control over that would give us access to water. And water, you can make oxygen, you can make hydrogen, you can drink the water, you can use it for agriculture, water is really foundational.
For life.
Exactly, and for establishing a sustained presence on the surface of the moon.
When we talk about this mission to space, where do we rank in comparison to other countries?
Right now, China is considered by many to be ahead of us in the return to the moon. Obviously, we were there. We had many missions to the moon already, but we haven't been in 50 years. And China has a roadmap that gets them a sustained presence on the surface of the moon by 2035.
And what does that mean in the grand scheme of things?
That means that they could establish control over critical resources on the surface of the moon before we do.
It's not just shooting for the moon, but Mars as well. When we come back, a conversation about the potential for life on Mars and recent discoveries just released. The big question scientists are itching to definitively answer is, are we alone in life? What other life is out there? And they're turning somewhere close within this solar system. NASA Solar System Ambassador Crystal Kaya joined me for the Sky Above's November episode to discuss life on Mars and where that research stands today. Why is Mars such a high priority in research versus maybe other planets?
There's so much exciting stuff to talk about with Mars. You can talk about it in terms of like planetary evolution and climate and all kinds of things. But I think what it really boils down to is that Mars represents one of our best opportunities to answer this fundamental human question of, are we alone in the universe, right? Mars had, rivers and lakes and a thicker atmosphere and a warmer climate and all of these things that we know, at least for how we understand life here on Earth, kind of to be essential for life. And if you ever look at Mars through a telescope, you can see these darker and lighter surface areas. You can see the polar ice caps. With more detailed images, you can see mountains and valleys and floodplains. Like, these are things that you could see on Earth looking at a photo of a desert, right? And so there is something just so tantalizingly familiar about Mars, right? In that if there are all these similarities and all these similarities for its past, if life evolved here, why not there?
In September of this year, NASA did just announce new findings. Let's talk about these findings. I think we're seeing some of the visuals from Perseverance right now. What did we discover here in September?
Yeah, so this is so exciting. I was actually so excited about this. I had the live feed playing in the car on the way to drop my son off at school because I didn't want to miss the announcement. So on September 10th, NASA announced that the Perseverance had imaged and cored back in 2024, but they released this kind of finding now after doing some additional analysis, that Perseverance had imaged and cored a mudstone in the Jezero crater that had textures and chemistry that were consistent with potential biosignatures. So essentially, this is possible signs of ancient microbial life. Now, that sounds so exciting, but I think it's really important to pause there and step back and say, okay, this is very exciting, but it's potential sign of life. This is not proof of life. And I think, any good science requires us to hold excitement and skepticism at the same time. Yep. And that's what's happening here. So really exciting finding potential biosignatures on Mars.
So how are we going to verify?
Yeah, so to verify, that's the tricky part from Mars. So obviously from where it is, we've got images. It was able to do some basic analysis on the samples that it took to be able to identify organic carbon, iron phosphate, iron sulfide. These are compounds that often occur on Earth in microbially influenced oxygen poor environments. So we have all of this data, all these images, but really to take it to the next level, that sample has to get back to Earth, right? Yep. Perseverance has done a phenomenal job, but it has taken it about as far as it can. And the next step is really those samples have to get back here to Earth, to a laboratory with the brilliant minds here on Earth to actually analyze it. And what's so tough is that in the meantime, the answer to this question of is this a biosignature is out there lying in a sample tube on the surface of Mars, just waiting for us to find out.
Those were just a few of the fascinating conversations we've had on The Sky Above. I'm your host, meteorologist Leah Pezzetti. We have new episodes coming every month in 2026 as well. Stay tuned as we continue to keep our eyes to the sky.